This is called a numerical Python. So NumPy is a fundamental package for scientific and numerical computing in Python. It's an indispensable tool for machine learning because it provides high performance and multi-dimensional array of objects called ND array. This is called n-dimensional array, along with a vast collection of mathematical functions to operate on these arrays efficiently. Okay. So why NumPy is essential for machine learning? Machine learning algorithms perform complex mathematical operations on large datasets. Standard Python lists are too slow to and memory intensive for these tasks. NumPy overcomes these limitations in several key ways because it have these advantages. It have high performance, and so it's memory efficiency. We are using arrays, and we also vectorization. NumPy allows you to perform batch operations on arrays without writing an explicit loop. These concepts known as vectorization results more concise and readable and fast coding. Mathematical functionalities, it provides a rich library of high-level mathematical functions. Its ecosystems foundations, libraries like Pandas, Scikit-learn, TensorFlow, and PyTorch are built on the top of NumPy. Okay, so we'll learn what is array. So in NumPy, we will mainly dealing with the arrays. In Python, an array is a data structure that stores a collection of items the same data type. Okay, while in Python, built-in list can hold items of different types. An array is specialized for homogeneous data, which makes it more memory efficient and faster for numerical operations. Okay, there are two ways we can store the number of data. One is called a list, other is called arrays. In the advantage of array is that it is homogeneous. We can store only one type of data. If you are storing a numerical data or like integer, only integer we can store. So this advantage that it will be very faster and memory efficient. In list we can store different type of data types, but it is not fast as array. Okay, the syntax to create array is array. We have to give the data types. So we have different type of short forms for this one. So this is D, B. D is for a double. This is a floating point data type, and if you are I, this is represent an integer, and B is for Boolean, etc. So we have to give the small weights here, and we have to give the value of list. So how many values we have to stay? If you want to say 1, 2, 3, etc., the list you can give here. Okay, what is the advantage of arrays over a variable? So in variable we can store only one type of data. So in a variable x is equal to a, x is equal to 1, it can store only one value. So if you're giving x is equal to 2 in the next line, this will go. Okay, that's why if for storing multiple data you won't need an array. So in array we will store multiple datas. Okay, so it's like we are storing different datas in baskets. Okay, so let's see, this is the first basket which will give us 0. This is called indexing. We will give the address of this in array as 0, 1, 2, 3, etc. in consecutive numbers. In the 0th array we put 1, and the first array we get 3, and the second array we get 8. So that's why we store this data, and this is called index position 0, 1, 2, 3. You can also give the negative inverse indexing position. You start with the last with the -1, -2, etc. You can start here. Also you can give some indexing, because if you want to leave with the last number, etc., you can use this will be helpful. Inverse indexing will be helpful in that cases. Okay, if you are considering array, there are different type of array. Maybe it's a one-dimensional array, or it have a store in only one dimension. So if you are storing number in rows and columns, this is a two-dimensional array, and we can extend this one in the third dimension also. This is called a three-dimensional array. This can store more data. Okay, so this is an introduction to array. Then if we are giving numbers to the two-dimensional array, we have rows and columns. Is it? So this is your row, and this is your columns. Okay, so you have to give the rows as 0, 1, 2, 3, etc. The first one is given as 0, 1, 2, 3. This is a negative indexing, and for this one we have to give 0, 1, 2, 3. Okay, for the first one first number will be for the row, and the second number will be your column. So if you take as row as 1 and my column is 1, so I can go for the second row. This is my row, and if you take column, this is, so I can pinpoint my number 5 as a 1 1 in the two-dimensional array. Okay, so the key characteristics of array is it's a homogeneous data. It can store only one type of data, and it have high performance, and it is also we can handle with the multi-dimensional array. In array, we will store the memory as like this. So the first the bit, the data here will be stored here, and the consecutive numbers are stored in the memory locations in the RAM memory. Okay, so I also saw we have a list and array, so we can just compare the list and array here. Okay, the features, the Python list, Numpy have this array. So the module Numpy contains array, and how we create list. The list is my list 1 2 3. You remember this is a square bracket here. Okay, for creating array, we have to follow my array np.array 1 2 3. Okay, so what is a build dependency? So this is built-in. We don't need any type of modules to import it. No import needed. But if you are using array, you need to import Numpy as an. So for the first code should be you have to import the Numpy. Okay, and then handling, we can handle heterogeneous. This contains integers, characters, and strings, etc. Or Boolean expressions we can handle with the heterogeneous data. But in the case of Numpy, it should be array, it should be homogeneous in nature. The operations, for the list we use loop statements. Okay, we start from here, and for x square, we give whatever list in the list, we should do one for loop, and we give the whatever values here will be done, and we do a loop to execute this list. But in the case of Numpy, we do a vectorization. We can do all these operations in a one go. Okay, now we will discuss how we can implement the array operations using Numpy. The first thing, you have to import your Numpy. We give a name as NP. So NP will be a short form of Numpy. We can, wherever you need Numpy, you can give us NP as a short form. Okay, so the first thing is to create Numpy operations, create an array using Numpy. So first you have to give a print statement creating arrays, and this is A0. This is creating, this is the name of your array, np.arrange 6, which means that is array is start from 0 to 5. The elements are 0 1 2 3 up to 5. Then print, we can give a print statement array from range A0. This is your array name. So wherever you need print statements, you can give, that will help to identify your program well. Okay, so whatever cells there you can do, have to run it. Okay, so this is our creating our array. This is 0 1 2 3 up to 5 we created. Okay, so we can also create, if you want to create an array of 0 2 4 6 etc., you can give a statement as a1 is equal to np.arrange 0 10, this last element, then you have to get the 2 means what is the gap between these two elements. Okay, that you can give. So if I run this one, so I get a 0 2 4 6 2 etc. Okay, so for creating a two-dimensional array, which means a matrix of zeros, okay, so we can give the statement last like this, a3 is equal to np.zeros 2 3. This is row, this is column. Okay, 2 rows and 3 columns are there. We can give print array of zeros at a3. Okay, then we can give a hyphen to make it beautiful, print hyphen into 20 times. Okay, so if I run this one, this will create an array of matrix 0 0 6 zeros here. Okay, so next thing is creating array from the list. Okay, if you already have a list, we can create an array. So as in tell, in square bracket, which means it is a list separated by commas. So this is array element 5 10 15 and 20. Okay, so I can run this statement. So give us a2 is equal to np dot array 5 6 15 20. Then it will create an array of 5 10 15 and 20. The another thing we can do is indexing. an array. Indexing means we can, if we give the index number, we can take the element from the array. So we already have an array of A2. A2 is this list, 5, 10, 15, 20. So if you want to get the data from the 0th element, this is 0th element, we can give the statement as print A2 0. This will print the 0th element. If you want the second element, we can give the statement as 1. Okay, so the indexes for 0 will be 5, and for 1 we have a 10. Okay, the next thing is combining two lists in to form an array. Okay, so if you want to combine two lists to form an array, so A is equal to np dot array. We have, so now here we are using three lists. We have 3 4 5 6 4 and 9 4 6 5 8, and also 9 5 7 6 8. These are different lists. We can combine using this statement np dot array. Then we can form a single matrix. Okay, this is 3 by 5 matrix we can get. Okay. The another thing is slicing of array. So slicing means we will cut out some portions from the array. So we already have an array called A. So if you want to cut some portions, so if I want to cut my first row, I have to give this command print row A. So this is represents this represents the row, and this represents the column. Because if I give it to 0, this is the 0th row, and I give 1 2 3, which means that the columns of this I have to give the from 1 to 3. So if I want to give the entire column, I can give an empty values, only the column is given. Okay, if I run this one, I will get the first row. So if I want to get a specific portion from this one, I can give the value. So from 2 to 3 is the column, that is actually the column 5. Okay, then we can do the different type of math operations in Numpy. One is called array math, that is called array math, and so we have to create two arrays from this one. This is x is equal to np dot array 1 2 3 4. This will create an array of 1 2 3 4, and y is equal to 5 6 7 8. These are the two arrays. Okay, so next thing is we can do the operations on this one. This is element wise addition. We can do the print addition. We can directly give a x plus y. So this will add these two operations, and we get 6 8. So 1 plus 5 we get 6, and 2 plus 6 we get 8, etc. All elements will be added. And next one is called element wise multiplications. We can do the multiplication also. For that we have to give the asterisk sign between these two. So this will multiply each element. Okay, each element we get 5 12 21 and 32, and finally we have a matrix dot product. Okay, for the matrix multiplication we have dot product. To create a dot product, you have to give the np dot x and y. So np dot x and y you can give, and also you can give a hyphens of 20 times. Okay, if you run this one, you get a dot product of two these matrices. Okay, so that's why we briefly discussed the different operations we can perform arrays using Numpy module, and there are a lot of operations, so you can try yourself. And the next thing we will do the other modules like pandas, and we have familiar with the plotting modules, and also we will learn how we can deal with the algorithm using scikit-learn.